This is Zach, a PCB designer. After my colleague Wilfred has set up the layout design and imported the mechanical definition, I have joined the team design session and will help with part placement and defining rule areas. We are both working concurrently on the same database without the need to split the database to complete our work. Wilfred can be seen working on the right-hand side, meanwhile I am working on the left-hand side. Wilfred is working on placing the FPGA and the power supply. The power supply is a logical physical managed block that is instantiated multiple times with different voltages. My initial focus is on the critical DDR4 and VREF components. We will use the planning groups that were defined by the hardware engineer Nicole in the schematic. First, I will place one of the DDR4 groups. In the Component Explorer, I can see clearly which parts need to be placed together to complete this group, thanks to the cluster assignments that Nicole completed earlier. I will drag the DDR4 planning group onto the board and place the first DDR component group. So with the top level DDR4 planning group on the board, I will now place the sub-placement groups sequentially for the 4 DDR chips. And finally, the VREF planning group can be seen placed above the 4 planning groups. So with the 4 planning groups placed, I can now place the first DDR chip from the DDR4-2 planning group, and then arrange all of the decoupling capacitors. The planning group for the capacitors could be seen hidden there behind the chip, and I'll use the arrange command to arrange all levels of the decoupling capacitors onto the board. Prior to arranging, I pushed that planning group to the bottom of the board, since I required that these capacitors be on the bottom layer. Now I can begin arranging a few of the decoupling capacitors in the desired topology around the first chip. So the first DDR chip and the decoupling capacitors have been placed, and Wilfred is beginning to place the planning groups for the decoupling capacitors surrounding the FPGA. I will now arrange the discrete components located in the VREF planning group above the 4 DDR chips. So using the arrange command, place all the capacitors on the board and arrange them to my desired topology. We can see Wilfred has placed the FPGA decoupling planning groups and is beginning to arrange those components. So with the VREF components placed and arranged, I can now move on to finishing placement for the remaining 3 DDR chips. I will use the powerful circuit copy command to achieve an identical placement pattern for these last 3 DDR groups. So using the circuit copy command, I can copy the DDR chip as well as all of the decoupling capacitors and paste them down here to finish placement. And finally, we have the termination resistor planning group here that will move off to the side. Now that part placement is complete, Wilfred has exited the team session, and I will move on to drawing rule areas and relate them to rule schemes that the hardware engineer Kyle defined in the constraint manager. The rule areas will encompass the 4 DDR chips and the FPGA component to allow for different trace widths and spacing in these dense areas. Now that we have placed all the parts and rule areas, Wilfred can move on to FPGA optimization. Now that we are done with our component placement in Xpedition, I wish to send an incremental update to the mechanical assembly in NX. To accomplish this, we will use the MCAD collaborator to send a proposal to the mechanical design. This proposal will only include the information that has been modified in my design. This makes it easier for the mechanical engineer to identify changes that are coming into the printed circuit card assembly.